Folks, today we're going to start factoring. So what is factoring? Well, we're going to talk about that. In order to understand factoring, you need to know what a factor of a number is, and then we're going to use that information and that knowledge to help us factor an actual polynomial. So the first question we need to answer is, what are factors of a number and what does it mean to factor a polynomial? Well, factors of a number are literally numbers that when multiplied together equal that number. All right, so basically you're breaking apart a number into its factors. So let's do an example. So if I have something like the number 32, okay, what are some factors of 32? Well, we know that 1 times 32 is 32. So 1 and 32 are factors of 32. What else? What are two other pairs of numbers that when multiplied together can give me 32? Well, you have 8, and you have 4, you have 16, and you have 2, okay, and so on. So there's some of the factors of 32. There are things that when multiplied together equal 32. All right, but that's just talking about a number. So what is it when you have a polynomial, which we know from previous things that we've talked about, means you have variables and you have different exponents for things. So how would we go about pulling a polynomial apart into the numbers that, or the expressions that multiply together to give you that polynomial? All right, and that's what we're going to do. We've multiplied them already. All right, we've done multiplication of polynomials. So basically now what we're doing is the exact opposite of that. All right, we are going to actually pull them apart. So we're starting with the end product and then we're pulling it apart into the 2 or 3 things that were multiplied together to give us that polynomial. So that's where we're going to start. So let me give you an example. If I have something like x squared plus 8x plus 15, okay, that is my end polynomial. Okay, so I multiplied 2 things together to get to that thing. So what are the 2 things that I multiplied together to get to that polynomial? Well, I know that they're 2 separate binomial expressions. You'll have to excuse the pen here. It doesn't seem to want to write full lines. Either that or I'm going too fast. Right? I know that when I multiply x plus 3 and x plus 5 together, I'm going to get x squared plus 8x plus 15. All right? But what we're going to talk about is how you guys can figure out how to do that. So how to go from this to this. All right? What we were doing the other day when we were multiplying is we were actually going from this and we were taking that and multiplying it together to get to this. So we're undoing it. And factoring something is pretty much the same as dividing it. All right? But when you're dealing with exponents and variables, it becomes a little bit different than looking at a number like 32 and pulling it apart into numbers that multiply together to give you that. So we're going to focus on that kind of stuff. We're going to understand what factors are first, and then we're going to use them to actually help us factor polynomials. All right. So some of the methods of factoring that we will cover. All right, we're going to talk about GCF. That'll be the first thing. That is the thing you always are. All right, you're always going to factor first. Okay. This is we learned this because always done first when factoring. Now, is there always a GCF? No, there's not always a GCF, but you always would look for one and then move on from there. So sometimes you're going to just have a GCF, sometimes you won't have a GCF. Sometimes you'll have a GCF and then you have to continue factoring with the methods that you see below. We'll talk about them at a later time. Right now we'll focus on GCF, understanding what that is and how to go about factoring a GCF out of an expression, polynomial expression. All right, so what does the acronym GCF stand for? Those 3 letters equal 3 words, all right, and those 3 words are what make up what it is that we're going to do. And those three words are all actually mean something quite important in what it is we're going to do. So you probably have heard this acronym before, and it stands for greatest common. I'm not used to writing this slow. This thing does not keep up with me. Factor. What happened there? Push the button. Okay. So that's greatest common factor. All right. So greatest common factor. All three words are quite important. Obviously, we know what a factor is. We just talked about that. So a factor is a number that when multiplied by another number gives you the bigger number. Okay. Common means if I have a polynomial, this greatest common factor, this number has to be common to every single term in the polynomial. All right, and we'll get into that in a second when we actually show you an example. And then greatest is you're looking for the biggest number or variable or combination of the two that you can take out of the polynomial that we're talking about. All right, so the largest number, greatest, common, so it has to be in every single part of the polynomial, factor, so it has to be something that multiplies together with something else to give you that component of that polynomial. So let's talk about GCF. Let's talk about just giving a pair of numbers and figuring out what the greatest common factor is between those two numbers. So if I have a number like, or a pair of numbers like 5 and 50, all right, to figure out what the GCF of 5 and 50 is, I mean, some of you might be able to look at that right away and figure it out. It's pretty simple. But what we'll do is if it's something that you're not quite sure about, you can actually write the two numbers out. And you can start to list your factors. Now, 5 is easy. It's just 1, okay, and 5. And then 50 has a ton of them. 1, 5, 10. Pick them up. Pick one. I do it. 2. Throw that in here. 2. 25. All right. So, and then 50. Okay. So they're the factors of 50. Now, which one is the greatest common factor? Well, again, let's look back at the greatest common factor. To be the greatest number, so we're looking for the largest number that's common to both 5 and 50. And obviously, we just listed out the factors, so we're looking for a number that's the same between 5 and 50. That's the largest. All right. Obviously, 1 is the same between the two, but we're looking for the greatest one. So our GCF for this pair of numbers is obviously going to be 5. GCF for this is 5. Easy enough. All right. So that's an easy set of numbers to deal with. Okay. And if you get to listing out the factors for 5, you don't have to necessarily list out all the ones for 50. Once you get to the one that's the largest, and it's obviously common to both and the largest. So let's look at 45 and 54. All right, we're going to list out the factors. So how do you know whether something's a factor? Well, if you don't know it off the top of your head, punch it in your calculator. Obviously, 1 is always a factor of it. All right, is 2 a factor of 45? Well, if I punch that in my calculator, I'm going to get a decimal, so it's not. Is 3? Yes, it is. Is 4? It's not. Is 5? Yes. 6 is not. 7 is not. 8 is not. 9 is. 10, 11, 12, 13, 14, 15. Okay. We go all the way up to 45. All right. So they're the factors of 45. What about 54? Well, we got 1, 2, because it's an even number. 2 is never even number. 3. Okay. 4. 5, no. 6, yes. 7, 8, no. 9, 10, 11, 12, 13, 14, 15. All right, so we can continue to go. I believe the next one for this would have been 18, and so on. So I don't need to keep going because I can stop here because I can recognize right away what's the greatest number that's common to both. Well, I can find it in both lists, and that number is 9. Okay, so the GCF of those two. And again, do you have to list all these numbers out every single time you do a GCF? No, you don't. All right, but what you can do is if you see it inherently right away, just write out what the GCF is. I get it. Some people see it right away. Others need to list it out. And either way is perfectly acceptable. All right, so what about 21 and 25? All right, well, I can let you guys list those out. All right, and if you want, you can pause it here. All right, and kind of do it yourself. And then when you come back, here's the answer. All right, so between 21 and 25, there's really not a number other than 1 that goes into both. Okay, and then 40 and 50, again, if you want to try this one, go ahead. All right, and then 40 and 50, pause it, you come back. Here's your answer. Okay, so that's that. That's how you find the GCF. All right, now how will that help us with polynomials? Well, let's take a look at that. All right, but before we do that, we actually have to talk about finding a GCF with variables. So how do you go about doing it when now there's variables? Because you're going to see variables in your polynomials. That's what we know polynomials to have variables, different exponents all the time. So let's take a look at that. So 14 and 21 will be handled this way. Okay? 14, I would look up 14, 21, look up that, do that quick. That's easy enough. Number 1 is 7. Okay? Now, when I'm talking about J's and K's, okay, J is the second, and J. All right, so what are the factors of J? Sure. J and J. Right, we know that J to the second means just J, right? What's the factors of J? There's one of them. So what you're going to look at is how many J's are common to both J squared and J. Greatest common factor. There's only one that's common to both. Okay? So in my GCF, I'm going to have just one J. Now, with K's, I have K to the third, and I don't have any K's with the 21. All right, so it's not common to both. It doesn't fall with that C. It doesn't fall underneath of that. So if it's not common to both, then it's not going to be included in my GCF. So my GCF for this problem is going to be the numbers that I circled, so 7, and then the J that I circled because that's the one that's common to both. 7J is my GCF. Okay, no K's, like I said, are involved because it's not common to both. All right, try this example on the bottom here. Pause it, come back to it. When you come back, here's your answer. Welcome back. All right, check to see if you did this right. All right, so what's the GCF between these two? 4. Okay, is the number component of it, x, y squared. And notice again, no W's involved. Why is there no W's involved? Because there is no W's in both of them. It only happens to be in the one, so it's not common to both. I can't have it as part of my GCF. Okay, so what we'll talk about in the next video is how to actually use this and apply this to a polynomial so I can factor it out and see what two things are that multiplied together to give me that polynomial.